In September, LG Electronics introduced their new smartphone called LG Wing. It has two screens, and the upper screen can rotate by 90 degrees relative to the bottom screen. Many people were interested in this phone with a new design. As soon as I saw the commercial of this smartphone, I was wondering how they implement the rotational mechanism. As the advertisement shows, they use the spring, damper, and tag and slot mechanism. The thing that I was more interested in was how they found the optimal location of the hinge, which is the center of rotation. Depending on the location of the hinge, you have different results after 90 degrees rotation, as you see here. You can find the optimal location of the hinge for this smartphone using middle school level mathematics and geometry. Would you like to do that together? Hey guys, how's it going? I'm Professor Peter. Here we have upper part and lower part of LG Wing smartphone. And if you rotate the upper part, then you have this orientation. In order to have this symmetric status like this after 90 degrees rotation, you have to put the center of rotation, which is the hinge, at the optimal location. Here we have lower part and upper part of the phone, and let's put the hinge point H, and I'm gonna put other points names like this. Two shapes are the same, so the length of the line segments CH and RH are the same. The length of the HD and SH should be the same as well. Now, I'm going to draw the status when the upper part is rotated by 90 degrees. Here, using the fact that the line segment length CH and RH are the same, you can draw a line where the point H should be on. Let me explain more details. Here we have the 2 points C and R. We will try to find the special point H. The condition is that the distance from the H to C is the same as the distance from the H to R. Actually, there are many of such points. If you show all the possible H points, then you can get a line. Can you draw that line? First of all, using a compass, let's draw two circular arcs. Their centers are C and R respectively, and they have the same radius. Then we can have two intersections like this, and if you connect them, then you can draw a straight line. Actually, this line is the perpendicular bisector of the line segment CR. Any point on this line has the same distance to C and R. Therefore, the point H should be somewhere on this straight line. Now, let's go back to the smartphone figure. Now, you can draw a special line using C and R. On that line, we will be able to find the hinge point H. As I said, the line segment DH and SH has the same length. So using the same drawing technique, we can draw one more line using D and S. Now, we have two straight lines, and the hinge point H should be on both the lines. Where is it? That's right. The H should be on the intersection of the two lines. So far, we used the geometry and drawing technique to find the hinge point. However, in the actual product design, we need specific numbers and calculation results. So now, let's find the hinge point location using calculations. Let's say width of the phone is W and the height is T. After the rotation of upper screen, we see small extrusion. Let's say the length of the extrusion is E. And let's put the frame of reference on the left bottom corner. Now we can put coordinates of points using the frame of reference. Let's say unknown hinge point H has coordinates A, B. We don't know A and B yet. Our goal is to find A and B using the given information W, T, and E. As you see, the design is highly symmetric. So from the center line, you have the length T over 2 to the right end and left end. because the distance from the frame of reference to the center line is w over 2, x component of our point is half w plus half t. By the way, we have one more way to express the x coordinate of our point. First of all, horizontal distance from the frame of reference to the point h is a, because the coordinate of h was assumed to be a comma b. Next, what is the horizontal distance from h to r? This is the same as the vertical distance from h to r before rotation, because the vertical distance from the coordinate system to h is b, and the vertical distance from the coordinate system to r is t. The vertical distance from h to r is t minus b. This is the same as horizontal distance from h to r after the rotation of the upper screen. Therefore, x-coordinate of our point is a plus t minus b. Okay, we have two expressions for x-coordinate for point r. These should be the same. Now we have one equation. Well, we cannot solve this problem yet because we have only one equation, but we have unknown two variables, a and b. We need one more equation. This time, let's think about the y-coordinate of the point r. The total height is t, and this part is e, and this length is w. The y-coordinate of our point is t minus e minus w. We have one more way to express the y-coordinate of our point. Let's use the point h. The vertical distance from the coordinate system to h is b, and the vertical distance between h and r is w minus a. So we can get the y-coordinate from our point. So this is the second equation. If you write down the two equations, we have these simple simultaneous linear equations with respect to a and b. If you rewrite these two equations, you can get slightly simpler equations for a and b, and then you can add them together and divide by 2. Then you're gonna get a like this. In a similar way, you can get b like this. From the specifications of this phone, you can get the t value and w value. Let's assume that the amount of extrusion 8 millimeter, then you can get the numerical results like this. Did you enjoy this calculation process? It is not true that we always use high technology or high-level mathematics to solve high-tech product design problems. Remember, sometimes middle school level mathematics can solve a lot of engineering problems. Thanks for watching. See you next time. Bye.